Hello everybody. We are going to start a new unit called Polynomial Functions. It's going to be a nice change from what we were doing because it's not going to be so heavy on the algebra. There's still going to be algebra, but there's also going to be some graphing and some other aspects to it. So I think it will be a nice change for you. What we're going to be studying are functions that are called polynomial functions, as I said. So let's remind ourselves what a polynomial is. If you remember the things that you were factoring on the unit we just finished, those are all polynomials. So a polynomial has a degree. We're going to talk about that. And it has a certain number of terms. We'll talk about that. And then we're going to do some algebra called long division, which will look a lot like the long division you learned in, like, I don't know, 4th or 5th or 6th grade. But yeah, it's still a little different. So the idea of a polynomial is there are going to be terms, and it's only going to have one variable, so that's going to be important. But the ones you were looking at in the last unit also had only one variable. We'll put them in order by exponent, so the highest exponent will go first, and then the next highest, and so on, all the way down to the constant. We call that standard form. And we can set it equal to 0, and if we do, then we have a polynomial equation. So some examples of polynomials, we can have 3x to the 5th plus 2x squared plus 7. That would be a polynomial. Things that are not polynomials, we're not going to have like 3xy. We wouldn't have 2x to the negative 1 because if you notice, it says that all of the exponents are greater than or equal to 0. We also wouldn't have 5x to the 1/2 because it says they need to be integers. So there are plenty of examples of polynomials, also plenty of non-examples, but the basic idea for a non-example would be that it has two variables like this one, it has a negative exponent like this one, or a fractional exponent. So the first thing we're going to talk about is how we classify them, and these should be names that you're familiar with, but let's review them. We classify them or name them by two things: number of terms and degree. So the degree of a polynomial in one variable when in standard form is the greatest number of that variable in one term. So I'm not talking about how many of those variables there are in the entire polynomial. I'm talking about one term. So if we look here, degree, if it's a degree of 0, then there's not going to be any variables. So that'd be like 4. That's a constant. If the degree is 1, then one term will have a variable in it, and any other terms will not have a variable. And that variable can only have an exponent of 1. So x, which is x to the first technically, plus 9 would be degree 1, because if you look at the two terms, only one of them has an x and the exponent is a 1. That's linear. You guys know that. When you graph it, you get a line. If you have a degree 2, that is like this example here, where we do have two terms that have an x, but the term 4x squared has the most x's. That's 2 x's. So that's a quadratic. Remember, those are parabolas. And then getting into some that you've never seen before, if one of the terms has an exponent of 3, then and there are no higher exponents, that would be a cubic. And then at degree 4, the highest exponent would be a 4, and that's called a quartic. And if it's 5 or greater, we call that n degree. And we don't call it n. Whatever the number is, we put in place of it. So if it's 5, we call it 5th degree. If it's 7, we call it 7th degree. Okay, so that's by degree. And then there are names by number of terms. Okay, so if there's one term, remember that's a monomial. So that might be 4x to the 5th or 2x squared or 7. Okay, so these are separate examples. If it has two terms, that's a binomial. Example would be 5x squared minus 7 or 3x plus 11. Remember that terms are separated by plus or minus. So when you're first trying to figure out how many terms it has, I suggest you circle the pluses and minuses and then see how many things are between them. 3 terms will be a trinomial. So that could be 3x to the 4th plus 2x minus 9. Or it could be 3x squared plus x plus 1. Those are all both are trinomials. 4 or more, we just call a polynomial, which is kind of odd because they're all called polynomials. And then it's like we ran out of names when you got up to 4 or more, so we just call them a general polynomial. So that could be 3x to the 3rd plus 2x squared minus 3x plus 1. That would be a polynomial. Okay, so I'm going to pause in a second and have you do this next part, and then we'll come back to it. So what you're going to do is you're going to determine if each expression is a polynomial and one variable. And if it is, you're going to name it by its degree and the number of terms it has. So this first example, that is a polynomial. It's in one variable. The variable is x, and the degree is 3 because this term here has the biggest exponent, and it is a 3. So now you guys do the u-tries. All right, so this one is a no because you see you have x's and y's. This one is a no because you have a negative exponent. This one is a no. You need to recognize that when x is in the denominator, okay, that means you have x to the negative 1. Remember we were just doing that in those complex fractions. Okay, so D is a yes. Notice that the no's, you don't do anything else. You don't try to name it by its degree and the number of terms because it's not a polynomial, so you don't give it a name. D is a polynomial. It is a quartic, okay, because it's degree 4 binomial. E is a yes, and it's a quadratic trinomial. F is a yes, and it is a cubic monomial. Notice that we do put the word binomial or trinomial. That's the second word. That's the noun. Quartic and cubic and quadratic, those are all adjectives, so they come first. This one is a yes. Even though there is not a variable, we could think of the variable as being an x to the 0 power, right? Because that would be a 1. And so x to the 0 power would be the same as 8. So it is a polynomial in one variable, and it is a constant. And we usually just call it a constant. If that's all it is, it only has one term, and it doesn't have a variable, then we don't have to say constant monomial. Although if you did, I wouldn't mark it wrong, but we usually just say constant. This one is also a yes, and it is a linear monomial. And this one is a yes, and it is a cubic polynomial. All right, and then we need to make sure you understand degree, because There's always confusion when we look at a polynomial that is in factored form. Okay? When it's in factored form, you need to think about what would happen if you actually multiplied them back together. And that's how you determine the degree. So if I were to multiply these back together, my biggest exponent would be a 2. It'd be x squared and then minus 2x minus 15. But the x squared is what would matter. So the degree is 2. Okay, and k, if we did this one, once we multiplied all 3 of those x's together, we would see that we would get an x cubed. So it's a 3. On L, we're going to multiply these and these and these and these. So it's going to be 4. Notice what's happening? I really just have to count the x's when it's in factored form, because that's how many of them I'm going to be multiplying together, and that will be my exponent. But all I have to do is count the number of x's. So you guys do the next 3 and then hit play again when you've done them. Okay, so this one should be a 3. This one, now don't miss this guy out here, this one's going to be a 4. And then this one, don't forget this one out here, so this will be 5. So notice finding degree is a little bit different when it's in factored form than when it's in standard form. When it's in standard form, you are looking at the highest exponent. Okay, so the highest exponent when it's in standard form. The highest exponent will equal your degree. And when it's in factored form, you count the number of x's, okay, and including multiples if there's an exponent. Okay, and that will equal your degree. I hope that didn't confuse you. All right, so now what we're going to do is we're going to divide. So let's think about something for a second. If I take 12 and I divide it by 3, I will get 4 and there's no remainder, right? And that's because 12 is divisible by 3. But if I take 12 and divide by 5, I'll get 2 and a remainder of 2. And that's because 12 is not divisible by 5. So we're going to use that same idea, and we're going to divide one polynomial by another. And if the remainder is 0, then the divisor, that's what we're dividing into, is a factor. Okay, so what we're going to be doing is we're going to be checking to see if we have factors. And we're going to be doing it by using long division, which will look very much like long division, like I said, that you learned way back when. And then we will check our answer by multiplying back together. So this is going to take some practice, and I do recommend you watch this a couple of times to help you. These are not super fast at first, but then you will get better. Okay, so what we want to do is we want to determine whether x minus 8 is a factor of x squared minus 7x minus 11. So what I'm going to do is I'm going to do long division. So remember, what you're dividing into always goes inside the little box thing, and then what you're dividing by goes on the outside. Now, when you are doing these problems, you actually will only look at what's here as your first term, your term with your highest degree, to determine or decide what you have to multiply by. Okay, so let's just go over here real quick and make sure you remember, like if we would divide 412 by 2. Okay, so we would say, all right, how many times does 2 go into 4? And it goes in 2 times, so we put a 2 here. and then we multiply the two 2's and put what they get when we multiply them here. Then we draw a line and we subtract. Okay, so then we bring down this number and we look to see how many times 2 goes. This 2 goes into that 1. It won't go in at all, so we put a 0 and we bring down a number. And then we see how many times 2 goes into 12. It goes in 6 times. We put the 6 at the top, multiply the 6 times the 2, put that there, draw a line, and subtract. And here we won't have a remainder. Okay, so we're going to use that same idea to do this problem. But like I said, we're only going to use the x that I circled on the outside. So what do I have to multiply x by so that it becomes x squared? Okay, so what do I multiply x by so that it becomes x squared? Well, I have to multiply by x, correct? But you're going to want to put this over the middle term, not the first term. You're never going to put it over the first term. And that's because we want to line up the x's with the same exponent. So we want to put it there so those line up. Now, remember what I did over here? Then I took what was on top and I multiplied it by what was over on the left. But this time when I multiply, I do have to use this entire binomial here. Okay, so I have to use this entire binomial when I multiply. So the x that's on top will be multiplied by this x minus 8. And we distribute, so that's x squared minus 8x. Now here, guys, I really want you to do this. Draw the line and change the signs. Why do we change the signs? We're subtracting. And if you don't change the signs, you will most likely get it wrong. So just go ahead and do it. So the first two terms really better subtract to 0. If they didn't, then you did it wrong, because that's how what we were trying to do, is to get the first terms to add to 0. Now I have negative 7x and 8x, so that is an x. And then remember what I did over there? I brought down the next term. So it's minus 11. Now I do this again. I go over to my x that's on the left, and I say, all right, what do I have to multiply that x by so that it matches this x exactly? And that would be a positive 1. So now I will multiply and notice here again. Okay, so notice now the constants match up. Okay. And so I multiply the 1 that's in the green up there by the x minus 8 that's on the left. I draw the line. I change the signs. It means I change the signs on the bottom. Whatever's down there is positive becomes negative. What's negative becomes positive. And those first terms better add to 0. Better cancel. And negative 11 plus 8 is negative 3. That is my remainder. And then we should check it. Okay, so we should take x minus 8, and we're going to multiply it by x plus 1. And when we do, guys, remember to FOIL. We get x squared minus 7x minus 8, but we need to add in the remainder of negative 3. Okay, so a negative 3, that's our remainder. Let's highlight these to match. Oops, that's a little dark. Let's try a lighter color. Let's try light blue. This negative 3 is this negative 3 here. Okay, so that's x squared minus 7x minus 11. That was what was in the box. That's what I was trying to get. That's what I was dividing into, and so it worked. So here's the question. Is x minus 8 a factor of x squared minus 7x minus 11? And the answer is no, because there's a remainder. I'm going to do one more, and then I'm going to have you do the other ones, and I will put them in here for you in the content library. All right, so let's do it again. We draw our box. X minus 5 goes out here because that's what we're dividing by. X minus 28 goes here. Now, I'm going to just use this X, and I need to figure out what times X will give me X squared. And that'll be an X, right? Well, where do I put it? I said I was supposed to line it up. Remember up here I lined up the yellow ones and the green ones? And there isn't one to line up. Okay, so here's one extra thing you have to know about these problems. We have to have some term for every exponent. So I've got an X squared, and I was going to have, and I've got a negative 28, but what I don't have is an X. But if I just put an X there, now I've changed the problem. That's not what this was. So it needs to be a 0x, because that won't change the problem. So notice what I have here. I have a squared term. This would be a first term. And then this would be no x's. Okay, so all of my exponents are represented. I have x squared, I have x to the first, and then x to the 0. So now I can divide. All right, so we're going to multiply it by x. So when I multiply the x on top, and look what happened. Now, these lined up. So when I multiply by the x on top that's in yellow, times the x minus 5 out here, I get x squared minus 5x. Now, you might say, why did I make it a plus 0x? It really doesn't matter if you make it a plus or a minus. It's going to work the same. But let's just not confuse ourselves. Let's just make a plus a 0x. All right, so I drew my line, and now I change my signs. So the first terms better cancel. Add to 0, they do. And I get a 5x. And then I bring down my negative 28. So now I do it again. What do I multiply x by so that it matches 5x? That'll be a 5. And look here what I have. Now I've got my constants lined up. And so 5 times x minus 5 is 5x minus 25. Draw the line and change the signs. And I get a remainder of negative 3. So let's try it again, make sure it worked. So we've got x minus 5. Here's our check step. And x plus 5, which hopefully you recognize is the difference of squares. So it's x squared minus 25, but don't forget our remainder, which is a minus 3. So that's x squared minus 28, and that checks. All right, so I have 2 more problems there I would like you to try, and I'll put the answers or the work here in the content library, and then you have a homework assignment. This one's going to be due too, because every time we have homework that's due, that means points that you can get just for doing it. And then the answers are provided. So I really recommend you try the problems, as many of them as you can. So do the 2 above the homework and then all of the homework. But the only thing I'll check is the homework. So I'll just be checking page 5. And we will go over any questions and do a little bit more practice at the beginning of next class.